Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome everyone. Today we'll explore world models, the brains behind autonomous driving. They predict and make decisions in complex environments, integrating sensor data with techniques like 3D occupancy grids and semantic masking. Machine learning, especially reinforcement learning, helps them learn and improve over time. We'll also discuss ongoing research challenges and emerging technologies empowering world models. What are the key challenges faced by autonomous driving systems that necessitate the use of world models for effective prediction and decision-making?
Autonomous driving systems face several key challenges that make using world models essential for effective prediction and decision-making. First, think of the real world as a busy playground filled with many different activities and surprises. Just like a child needs to be aware of other kids in swings while playing, autonomous vehicles must navigate complex environments with various moving objects, such as pedestrians, other cars, and obstacles. To do this safely and efficiently, these vehicles need to predict what might happen next, which is where world models come into play. World models help these systems understand and imagine future scenarios by synthesizing and interpreting huge amounts of data from their sensors. Like a puzzle that, when completed, shows a clearer picture of what is going on around them. However, there are challenges. One issue is that the information gathered by sensors can lose important details, similar to trying to draw a picture from a blurry photo. If the model ignores too many details, it risks making mistakes. Additionally, just like how humans can remember past experiences to make better decisions, autonomous systems need long-term memories to learn from past situations. This is difficult as these systems can forget important information over time, limiting their ability to learn and adapt. In summary, the challenges of navigating complex environments, accurately predicting future scenarios, retaining important memories, and dealing with data limitations are all reasons why world models are crucial for autonomous driving systems.
How do world models integrate sensor data to create predictions, and what methods or techniques are commonly used to enhance the accuracy of these predictions within autonomous driving systems?
World models integrate sensor data to create predictions by combining multiple types of information from the vehicle's environment, much like a chef using various ingredients to make a delicious dish. For instance, by incorporating both LiDAR point clouds, which provide a 3D view of the surroundings, and visual inputs, like camera images, these models can predict future driving scenes, including what the vehicle might see in the next moments. One way this integration enhances accuracy is through the creation of 3D occupancy grids. Imagine these grids as detailed maps that show where things are located in the environment, helping the vehicle understand how to navigate around obstacles effectively. Some models like Ockworld and Think2Drive use this 3D information as input to foresee changes in the surroundings and plan the vehicle's actions accordingly. To improve the predictions further, techniques like semantic masking are used. Picture this as a filter that helps the model focus on the important features of the environment while ignoring irrelevant noise, much like how you would wear sunglasses to reduce glare while driving. Additionally, to deal with variations in data, models can utilize balanced sampling, ensuring that all types of driving scenarios are represented fairly during training. This balance helps the models learn better and become more robust in unexpected situations. Overall, by employing these methods, world models transform raw sensor data into meaningful predictions, allowing autonomous vehicles to navigate their environments with a level of intuition and sophistication.
What role do machine learning techniques, particularly reinforcement learning, play in the development of world models for autonomous driving? And how do they contribute to the continuous improvement of prediction accuracy and decision-making?
Machine learning techniques, especially reinforcement learning, play a crucial role in developing world models for autonomous driving. Think of reinforcement learning as a kind of training process, similar to how a puppy learns tricks by receiving treats for good behavior. In the context of autonomous driving, the vehicle learns from its experiences and improves its decision-making over time based on rewards or penalties it receives for its actions. World models use this reinforcement learning approach to evaluate potential future scenarios. This is like a child imagining the possible outcomes of different choices before deciding what game to play. By predicting what might happen next, these models help the vehicles plan their actions effectively, even in situations where detailed maps or complete information are not available. For instance, a system like model-based imitation learning, MILE, combines learning about driving dynamics with driving behavior. It uses past experiences, offline datasets, to teach the vehicle how to navigate in various environments, enabling it to compensate for missing information by imagining what could happen next. This imaginative capability leads to better planning and helps the vehicle adapt dynamically to changing circumstances. As these world models learn and evolve through machine learning technique, they continuously improve their prediction accuracy and decision-making abilities. This learning process, akin to a student mastering a subject through practice and experience, allows autonomous vehicles to become more skilled at navigating complex real-world situations with precision and safety.
Can you elaborate on the ongoing research efforts aimed at addressing the limitations of current world models in autonomous driving, and what specific advancements are being pursued to enhance their effectiveness?
Ongoing research efforts aimed at addressing the limitations of current world models in autonomous driving focus on several key areas to enhance their effectiveness. One of the primary challenges is the gap between simulated training environments and real-world conditions. Think of this as practicing a sport in a perfect gym, but then playing a match in a messy field with unpredictable conditions. Researchers are working to develop more realistic simulations that better mimic the unpredictability and variability of real-world driving scenarios. This includes addressing differences in physical properties, sensor noise, and the occurrence of unexpected events. Another area of focus is improving the computational efficiency and memory scalability of world models. Imagine trying to remember every detail of a story. Having a way to summarize important parts can make recalling the story easier and faster. Similarly, researchers are exploring ways to help world models retain important information over long periods, while discarding irrelevant detail. This would enable autonomous vehicles to adapt more readily to changing environments, enhancing their decision-making capabilities. Additionally, there is an emphasis on overcoming data scarcity, especially in specialized tasks. Researchers are innovating solutions that allow these models to generate predictive scenarios from historical data, which helps in training autonomous systems even when collecting real-world data is challenging. Through these advancements, researchers aim to create world models that not only predict and simulate future scenarios more accurately, but also reflect a form of intuition, allowing autonomous vehicles to navigate complex conditions with greater precision and reliability. This ongoing work signifies the exciting potential for continued innovation in autonomous driving technologies.
How do emerging technologies such as neural networks and deep learning contribute to the advancement of world models in autonomous driving? And what potential do they hold for enhancing the capabilities of these systems?
Emerging technologies like neural networks and deep learning significantly enhance the capabilities of world models in autonomous driving. Think of neural networks as a complex web of interconnected nodes, similar to how our brain processes information, allowing them to recognize patterns and make predictions based on vast amounts of data. These technologies contribute to the advancement of world models by enabling them to understand and interpret complex systems and dynamics. For example, just as a savvy gardener learns how to nurture plants by observing their growth patterns, world models can optimize driving routes and behaviors by analyzing traffic data, weather conditions, and other factors. This ability helps in not only ensuring safety and efficiency, but also in promoting environmental sustainability by minimizing emissions and reducing traffic congestion. Moreover, deep learning helps world models to adapt and improve continuously. Just like a student who learns more with every lesson, these models can become smarter over time by processing new data, refining their predictions, and enhancing their decision-making skill. This continuous improvement holds the potential to transform autonomous vehicles into responsive agents that can harmonize with urban ecosystems. In summary, the integration of neural networks and deep learning into world models empowers autonomous driving systems to navigate more effectively through real-world challenges while also contributing to environmental goals. This advancement signifies a promising future where autonomous vehicles can operate with greater intelligence and adaptability.
Thank you all for joining us today. I hope you found this discussion on world models for autonomous driving systems to be informative and engaging. Let's recap the main points we covered. Autonomous driving systems rely on world models to predict and make decisions. These models integrate sensor data and employ techniques like 3D occupancy grids and semantic masking to enhance accuracy. Machine learning, particularly reinforcement learning, enables world models to learn from experiences and improve over time. Ongoing research focuses on addressing limitations in simulation, realism, computational efficiency, and data scarcity. Emerging technologies like neural networks and deep learning empower world models with pattern recognition, adaptability, and continuous improvement, enhancing the capabilities of autonomous driving systems. We've seen how world models are essential for autonomous driving and the challenges and opportunities involved in developing them. I encourage you to continue exploring this topic and contribute to the advancement of autonomous driving technology. Thank you again for being here.